Hello everyone, welcome back to my channel. Today let's go over a medium level question that I just solved on my own. So I'm super happy about this and I'm very glad that I was able to come up with my own solution to this question without any assistance. So let's go over it and let me show you how I did it. So this is question 2 of Weekly Contest 495. It's a medium 4-point question. So basically you're given this list of events where you have an event ID and a priority, so it's a matrix. So let's go ahead and call this self.events is events. And basically you want to update the priority of whatever the event ID is to new priority, and then here you want to return the event ID of whatever event has the highest priority, and if they have the same priority, return the smallest event ID. If not possible, return -1. So basically let's just go ahead and create two sorted lists, because one of them, if we're going to update the priority of the active event, then we're going to emphasize the event ID so that we can do a binary search on that to find the priority, right? And if we want the highest priority, then why don't we just have another sorted list that emphasizes priority, puts priority as the first, and then event ID as the second, right? So let's call this self.first, self.second equals to two sorted lists. So this acts as a heap. And let's go through the events. So the event ID and the priority in events. Cool. So we're going to add, again, one of them we want to prioritize the event ID, and the other one we want to prioritize the priority, right? So that's going to make deletion and searching very easy, because if we want to delete from one, then it's just swapping the parameters to delete it in the other one, right? So basically, okay, so if we want to update the priority of the active event with event ID to new priority, again, we care about the first one because we want to find whatever the event ID of this is, right? So let's go ahead and run a binary search on self.first so that we can get the event ID in log time. So if self.first of mid of 0 is event ID that we're given here, then that means we want to update it. Okay, if we update it, then that means we delete this, and then we make this new priority, right? So that's kind of the idea for the update priority method. Cool. So in that case, we found what we're looking for. So we can just say old is going to be the event ID because we found it. And the old priority is self.first mid of 1, which was that. And the new is just going to be event ID of new priority instead, right? Priority. Cool. Okay, so now we can just say if old is in self.first, because this is a sorted list, it's actually going to be quicker than an end scan. So we can just say self.first.discard old, and then we're just going to always, so we don't even need this because discard basically throws an exception if it's not in there and takes care of that by itself. Otherwise, and we're always going to add new, right? Cool. So we're updating it, meaning removing the old in with a new. Cool. And then we also have to do the same thing with the other sorted list because of this, right? So let's call this old again. Is just going to be the so let's just call this old 2 is self.first mid of 1. Because the two heaps, the two sorted lists have the same things and them just swapped in order, right? So old 2 is going to be this, and event ID. Let's call this new 2 is going to be new priority in event ID. So the event ID does not change, right? Cool. So then we can say self.2.discard old 2 and self.2.add new 2. Cool. And then we just break it because we already found where the event ID is in the first list, right? Otherwise, if self.first of mid of 0 is bigger than event ID, because we're sorting, this sorted list is sorted by event ID, right? Then we're going to write my equals mid -1 because we don't have to find the other half, right? So if we print self.first and self.second, so I can illustrate this, let's just return a dummy -1 for now. Event manager object has no attribute to, oh, self.second. So you can see that this is sorted by whatever this is. And so here we're interested in the priority. Here we're interested in the EID. So the event ID is what we're looking for. And then again, if we're looking for 6, then we don't search this and we go down, right? Cool. So we're only interested in looking for that event ID because if we see event ID here, then you can see 9 is what we're looking for. So if we're on mid and we're saying this is less than, then we're just going to move the mid pointer up like this. Cool. So hopefully you guys understand that. And now let's print self.first and self.second again. This is basically the same thing with the second list. We're running a binary search on list 2 because we want to get the highest. Also want to delete, right? So removes and returns the event ID of the active event with the highest priority. So the highest priority is just going to be binary searching this list instead, right? So the highest priority is always just going to be this one because it's the priority and the event ID, it's sorted by this value. So we're just going to get self.second of -1 of 0, right? Cool. So now that we have that, we can see which target we're looking for. And now we're just going to find if multiple active events have the same priority. So in the case we're looking for 7, then the smallest one of the priority of the event ID is going to be 2. So let's go ahead and run a binary search on self.second. While left is less than or equal to right. Again, the biggest ID, let's just call this, let's see if this is X and this is Y, right? So let's call this self.second of -1 of -1 because this is going to be the biggest it's going to be. If we have a smaller one for 7, then we're going to look for that. So mid is left plus right divided by 2. If self.second of mid of 0 is equal to highest priority, then again, we're going to minimize Y with self.second mid 1, right? Cool. So if we're looking here, then we're going to say this is also 7. Whatever the biggest, highest priority is, we're going to update 5 to 2, right? Cool. So otherwise, if self.second of mid of 0 is too big, then throw away the right side. Otherwise, throw away the left side, right? So now we can print highest priority and Y. So now we're going to get the X and the Y that we want to remove, right? So if this thing will load. Why is this throwing a time limit exceeded? Let's do this. Is that the problem? Okay, so there's some problem here. Okay, so again, we're always looking to minimize, right? So we're going to move down even if we find something that's valid, right? Because if we get rid of, if we put these back, basically, if we're on 5, we're always looking for something that's smaller than 5 that's still 7, right? Cool. So now that we have that, this is what we want to remove from both lists because that's the highest priority. So the highest priority of 7 with the smallest event ID of 2, right? Cool. As denoted here. So we also want to remove that in both lists. So again, if highest PY is inside of self.second, or we can just say self.second.discard. Highest PY, if it exists, it's going to do it. If not, then we're not going to throw an exception. And then self.first.discard. On the other hand, Y highest P, right? Other way around, 7227. Cool. And so let's run this. And you can see that that's exactly what we want. So then we just want to return the smallest event ID. So we can just return y. So let's print highest p here. Okay, so if not self dot first, because if there's not self dot first, then it's not self dot second, because both of them have the same amount of elements. They're both being discarded and added at the same time, right? So we don't even need this. So let's run this. Okay, submit it. Okay, get rid of this print statement. Submit it again. And probably that. Let's make sure we don't have any other prints. And there you go. Passes all test cases. So again, I'm super happy that I was able to come up with my own solution to this question without any help and solve it completely on my own. So that's it for this video, and thank you for watching.